Today we are going to talk about measurement of physical quantities. Measurement of physical quantities. One may ask, what is even measurement? Measurement is the quantitative determination of a quantity. When do we take measurement? We take a measurement when we want to know how heavy a quantity is. One thing that I want you to take note of is, in science, any measurement that you do, you have to record them, and right after you do that particular measurement. Also, a measurement have two main things: figure and a unit or a dimension. Take note of that. Measurement should have a figure and a dimension or a unit. Very good. So, I've explained what measurement is. Somebody may ask, what is also a physical quantity? As I said, the topic is measurement of physical quantity. So, what is a physical quantity? Now, when we talk about a physical quantity is any quantity that can be observed and measured. Any quantity that can be observed and measured. Any quantity that can be observed and measured. And we have two main types of physical quantities. The first one that I want us to talk about is fundamental or basic quantity. Fundamental or basic quantity. You can also term it as fundamental or basic physical quantities. When we are talking about physical quantities. Alright. And then the second one is derived physical quantity, or you can say derived quantity. Derived quantity. Now, what is fundamental or basic physical quantity? When we talk about fundamental or basic physical quantity, we are talking about any quantity that cannot be expressed in any other quantity. A typical example is mass. We can talk about length, we can talk about time, luminous intensity, we can talk about amount of substance. So we have a table here which gives a summary of the basic or the fundamental quantities. And as I said earlier, we have 7 of them. We have 7 of the basic or the fundamental quantities. That are quantities which cannot be expressed in any other quantity. And the first one on the table, so we have basic quantity, we have symbol, we have SI units, and then we have symbol for SI unit. Now, so under the quantities, we have length, we have mass, we have time, we have electric current, we have thermodynamic temperature, we have amount of substance, and lastly, we have luminous intensity. So these are the 7 basic or fundamental quantities. Now, so they are symbols. So these are the symbols for them. And then we have SI units. Somebody may even ask, what is SI unit? When you talk about SI unit, SI unit stands for International System of Units. SI unit, International System of Units. So I want you to take note of that. So SI unit is here. We have, so the SI unit for length is meter, that of mass is kilogram, that of time is seconds, that of electric current is ampere, that of thermodynamic temperature is Kelvin, that of amount of substance is mole, and then that of luminous intensity is candela. And these are the symbols of the SI unit of the basic quantities. Now, maybe you've been here of SI units and also IUPAC. So I've explained what SI unit, or let's say the meaning of SI unit. Now, IUPAC is an abbreviation for International Union of Pure and Applied Chemistry. IUPAC. Maybe you've come across it because normally it moves with SI unit. So this is IUPAC. Let me write it for you. IUPAC. Maybe you've come across it, but you don't know the meaning. It's an abbreviation, and its meaning is International Union of Pure and Applied Chemistry. Yeah, so I want you to take note of that. All right. The next one is derived quantity. Derived quantity, because under the type, here we have fundamental and then derived quantity. Okay, so what is even derived quantity? Now, derived quantity is a quantity that can be expressed in other quantities. In other words, the derived quantities, as the name implies, derived, they are derived, or we obtain them from the basic or the fundamental quantities. So I want you to take note of that. So for the derived, unlike the basic that we have 7, the derived we have many. So I want us to talk about just 5 of them. And the first one is concentration. So the symbol for concentration is C, capital letter C, and then we have the SI unit being mole per decimeter cube. So it's the same. That is mole slash dm cube or mole dm cube. Then we write it this way. So any of them is the same, mole per cubic decimeter. Now this is telling you that the mole, like the unit is in a fraction form. So the mole is the numerator, and then the dm cube is the denominator. Take note of that. Under phrases, I believe you have done dimensions and you have a concept about what I just said. Okay, so that is the definition of unit, mole divided by volume. Very good. Then force. The symbol is F. Then the unit is Newton. And 1 Newton is the same as 1 kilogram meter per second square. 1 kilogram meter per second square. Take note of that. So here too we have pressure, and the pressure is P Pascal, and 1 Pascal is the same as 1 Newton per meter square. Then we have energy, that is Joule, and 1 Joule is equivalent to, or is the same as 1 kilogram meter square per second square, or Newton meter. Then the last one is velocity, which is the symbol is V, meter per second square as the SI unit. Then the definition of the unit, you have meter slash second or meter per second, meaning that the meter is the numerator and then the second becomes the denominator. So if you look at all these units under the definitions, you could realize that you have 2 or more of the basic or the fundamental quantities coming together to form the derived quantity SI unit. So that is the reason why we are saying that the derived quantity can be expressed in other quantities. In other words, they are obtained or they are derived from the basic or the fundamental physical quantities. That we have volume, which is expressed in either meter cube, centimeters cube, decimeter cube. We can talk about molar mass, which is also expressed in, that's the unit is gram per mole. Gram per mole. We have acceleration, and that one to the unit is meter per second square. We have a lot of derived quantities. Okay, so I want you to read more about examples of derived quantities and their SI unit. Okay, and the definition of the SI unit as well. Now, the last thing that I want us to talk about in this lesson is prefix. Prefix for SI unit. Prefix for SI unit. Prefix for SI unit. All right, we have 2 different tables here on the board. First one have to do with multiples, and then the second one have to do with sub-multiples. Okay, so under the multiples, you can see that we have positive figures, and then here we have negative. Now what I want you to take note of here is that when you write any number in mathematics, let's say you see 1, it is raised to the power 1, but you don't write it. When you see 10, it's the same as 10 exponent 1, because any number exponent 1 is the same number. Very good. So I want you to have that in mind. Anyway, so here we have 10 as a multiple, and then the prefix name is, or the prefix is deca. and the symbol is dA. Now we have 10 exponent 2, or 10 raised to the power 2 is hecto. We have 10 exponent 3 being kilo, exponent 6 being mega, exponent 9 being giga, and then exponent 12 being tera. So I want you to have that also in mind. Then we have the sub multiples, and then its prefix and the symbol as well. Under the sub multiples, we have 10 exponent negative 1, 10 exponent negative 2, 10 exponent negative 3, 10 exponent negative 6, exponent negative 9, and lastly, exponent negative 12. So the exponent negative 1 is called deci. Then the negative 2 is called centi. And we have milli, micro, nano, and lastly, we have pico. So this is where we will end today's lesson. So I want you to take note of all these things as a chemistry student. As we proceed, we are going to make good use of all these things. So this is just part of the intro. So take them serious so that when the time or the need be for us to use them in subsequent lessons, you will remember to make good use